Okay, we're going to be looking at using letter symbols to represent functions. Okay, so we've seen this in previous lessons where we've used n to find the nth term. So that's a way of using a letter to represent an unknown number using a letter. It's used a lot to generalise number patterns, which we've seen, and also for sequences, which we've also seen in the previous sessions. And they also use it to for functions and mapping diagrams, which we're going to have a look at today. So here's an example of a mapping diagram. You can see that we have a number here 2, and then the output is 8. So the input is 2, output is 8. Okay, if we want to find the function of this set of numbers, we're going to have to find the rule. Okay, so this is the same thing that we've done in the previous lesson. How can I go from 2 to 8? I add 6. Check it for 3 to 9, 4 to 10, and we know it's definitely plus 6. Okay, so in the last session we saw a form something like this. We had 2, add the 6, and we got the output to be 8. Okay, this time we want to know how is my mapping diagram going to look if I don't know what the number is. So if I don't know what the number is, I can call it x. I put it in to my function machine, and we know that the rule is adding 6. And then I'm going to have this number, whatever it is, and then I add 6. So I get the rule x plus 6. Okay, we're going to try the same thing for the rule double it and then add 5. Okay, so we have the rule, which is so multiply by 2, and then we add on 5. Okay, we want to know what the function is. So the function machine is going to be, we put something in, we times it by 2, and then we add on 5 to get the answer. If we want to have the mapping of this function, if I put x in and I multiply it by 2, I get 2x. Okay, and then that just means 2 times x, and then I want to add on the 5, so I get 2x plus 5. So for the mapping, I have x is mapped onto 2x plus 5, and that is my answer. Okay, so we've got some examples here. It says draw the mapping diagrams to illustrate each of these functions. So for the first one, we have got x is mapped onto x plus 5. We can choose what our mapping diagrams are going to have in it. Okay, so we can choose the numbers. So for this first one, I can say that I put in 1, add on the 5, I get 6. I can put in 2, I get 7. I put in 3, 3 plus 5 gives me 8. Okay, for the next one, I can do the same thing. I can choose any numbers. So I'm just choosing 1, 2, and 3 to keep it simple. So 1 times 3, so 3x is just 3. 2 is mapped onto 6, and 3 is mapped onto 9. 3 times 3 is 9. For the next one, I've got x is 1, so 2 times 1 is 2, add on 1 is 3, 2 times 2 is 4, add on 1 is 5, 2 times 3 is 6, add on 1 is 7. Okay, for this next one, you are going to write each of the following rules in symbolic form. So for example, add 4 can be written as x mapped onto x plus 4. Okay, so you're going to do the same thing with all of this. So for the first one, I'll do the first one for you. So A, we're going to add 3. Okay, so I have x, and then I add on 3. So I have x plus 3. So that's for part A. So press pause and answer these questions. When you're ready to move on, just press play for the answers. Okay, for 1b, we're multiplying by 5. So I have x multiplied by 5, so I've got 5x. C, subtract 2, so I have x mapped onto x minus 2. Divide by 5, x is mapped onto, dividing by 5 is the same as multiplying by the fraction, so it's a fifth of x, or you can have x divided by 5. Okay, for the next one, subtract 4, so it's x mapped onto x minus 4. For f, we have x is mapped onto 2x because it's doubled. Multiplied by 8, I have x mapped onto 8x. And then for halving, it's dividing by 2. So I take my x and I divide it by 2. Okay, so those are the answers for those questions. For this next one, you need to express each of the following functions in symbols. Okay, so similar to question 1. So for the first one, we've got 2 to 9, 3 to 10, 4 to 11, and 5 to 12. We need to know, how can I get from 2 to 9, 3 to 10? Okay, if I times it by 4 and then add 1, it will work for this one here. 2 times 4 is 8, add on 1 gives me 9. But if I try it for the next one, 3 times 4 is 12, add on 1, it gives me 13, so that does not work. So we need to think of another rule. I can try adding, so I've got 3 to 10, that's adding 7, 2 to 9, adding 7, so I know that I'm going to have, my mapping diagram is going to be x, it's mapped onto x plus 7. Okay, answer the next question, so press pause and then I will go through the answers when you have finished. Okay, for part B, we start with x, going from 2 to 10, 3 to 15, 4 to 20. We can see it's in our 5 times tables, so it's just 5x. For the next one, 2 to 1, 3 to 2, 4 to 3, 5 to 4. It's minusing 1 every time, so it's x minus 1. And then for the last one, 2 to 8, 3 to 12, and so on. We can see it's multiplying by 4, so it's 4x. So if I wanted to know what the what my output would be if my input was 50 for any of these, I just put it in 50 plus 7. So if my x is 50, my output is going to be 57. Okay, and it's a similar thing for the rest of this. If x is 50 here, minus the 1 gives me the 49, and so on. Okay, for these next questions, you need to draw the mapping diagrams to illustrate each of these functions. So you need to choose a few numbers and show the mapping diagram. So I'm putting in my number x, I times it by 2, and then I add on 3. So for the first one, I can have 1 is mapped onto, So 1 times 2 is 2, add on the 3 gives me 5. I can choose any number, so I could have 2, 2 times 2 is 4, add on 3 gives me 7, I could have 10, 10 times 2 is 20, add on 3 is 23. Okay, so answer the next questions on your own. I'm not going to go through the answers because you could choose a whole range of different numbers, but you should get the right idea. Okay, for these questions, you're going to describe each of the following mappings as functions in the symbolic form as above. So just a reminder, it needs to look something like this. So x is mapped onto, and then we need some kind of formula or expression. So you're going to go from 1 to 1, 2 to 3, 3 to 5, 4 to 7. Okay, so press pause, and I will go through the answers in just a moment. Okay, so for the first one, we have x mapped onto 1 to 1, 2 to 3, 3 to 5. That's going to be 2x minus 1. For the next one, I've got x is 1, 1 to 7, 2 to 11, 3 to 15, 4 to 19. If I multiply by 5, I would get 5, add on 2 gives me the 7. 2 times 5 is 10, add on 2 will give me 12, so we cannot do that. Okay, if I try, we could try a whole range of different numbers, but we know that the difference will tell us our multiplier. So here the difference is 4. So we know it's going to be 4x, and then I need to add on 3. So try it for another number, so 3 to 15. 3 times 4 is 12, add on 3 gives me the 15, so we know that works. For this one, it's going to be 3x and then minus 2. And then for the last one, we have got 10x and then add on the 1. It says put the same number through each of these function machines. Okay, so I want the same input for both of those. And then I need to work out what the output is. So if I was to put in, for example, 30, 30 divided by 2 gives me 15, 15 minus 3 gives me 12. So now I'm going to put in the same number, 30, minus a 2 gives me 28, divide by 3, and I'm going to be left with a decimal number. Okay, you need to repeat this with other numbers, so try a few more examples for yourself. And now you need to see if you can find an input that gives the same output for both of these function machines. So my input values have to be the same, and my output values have to be the same. Okay, so press pause and have a go at those, and when you're ready, press play and I'll go through the answers. Repeating with other numbers, you could have 1,000 different answers, so I'm not going to go through that. But the next one, can you find an input that gives the same output for both of these functions? It's going to be 14. Okay, so if I put in 14, divide it by 2, I get 7, minus the 3 gives me 4. Put in 14, minus the 2 gives me 12. 12 divided by 3 gives me 4. So here we can see that my input values are the same and my output values are the same. Okay, for this next question, it says the diagram shows a number machine, okay, or a function machine. write down the output when the input is 8, and then find a number to input so the output is the same as the input. So part A is quite basic, so we're putting in 8 and we need to find out what the output is. For the second one, my input value has to be the same as the output value. Okay, so I need to have the same numbers for the input and the output. So press pause, and then when you're ready, you can press play and I'll give you the answers. Okay, so for part A, we want to put in 8. So there's my 8, put it in, I times it by 5, which gives me 40, minus the 40, and my output is going to be 0, so my answer is 0. For part B, I want to find a number so that the input is the same as the output. Okay, I'm minusing 40 here, so that should help us a little bit. If I put in 10, times it by 5, that gives me 50, minus the 40, that gives me 10. Okay, there's a bit of a extension question for you to do. I'm not going to read it out. You can press pause, read through it, and then you can complete that if you're happy to. Okay, and for those of you who are understanding this really well, you can try this activity question as well. Okay, so it just goes into a little bit more depth, and it's a bit of an investigation, I guess. So press pause so that you can read it all carefully, and then you can answer the questions. If you find this one too difficult, do not worry. If you grasp the main concept of the lesson, then you're doing well. If you find it relatively easy and you want to try something that extends your knowledge a bit further, then you can try this question. Okay, here we've got let's move this. Here we've got some sort of SATs test questions. This isn't compulsory for you to do, okay, it's not compulsory, but if you want to have a go at them, then you're more than welcome to. I thought I'd just put it up anyway, so you can get an idea of what the questions would look like, or when you come to do GCSEs or any other exams that you might be doing in the future. So there's question 1 and 2. You can press pause and read through it and answer the questions. And then the next questions 3 and 4 are here. Okay, so there's nothing really new here. It's just written in a different form. Okay, they start off easy, so questions 1 and 2 are relatively easy, and then 3 and 4 get more difficult.